Okay, moving on. Now that we've simplified, we are going to solve equations with radicals in them. So here's what we need to do. Always want to get x by itself, isolated. If the x is squared, we're going to square root both sides. If x is underneath the square root, then we're going to take the square root of both sides. Okay. So, first off, we have x times square root of 3. This is theoretically the same thing as, 3x equals 9. Okay? X is being multiplied by something. What do? We divide by it. And then we get an answer. We're going to do the same thing here, just the only difference is what's attached to the x is a radical. So we need to divide by that radical. So we get x equals 9 over square root of 3. As we've learned previously, we can't have a radical on the bottom, so we have to multiply, like so. Now on the top, that just simply gives us 9 times the square root of 3. And at the bottom, remember, it gives us the square root of 9, or simply just 3. And now we can reduce. Remember, if it's going too fast, you can always hit pause. Slow it down, rewind. 3 goes into 9 3 times. So my final answer is x equals 3 times the square root of 3. Same thing here. What's attached to the x? By multiplication, a square root of 4. But in this case, instead of dividing by square root of 4, we can simplify this. This is just the number 2. So now, just like we talked about in algebra, we can simply just divide by 2. Now, you don't have to write this down, but maybe you didn't see that at first. Maybe you divided both sides by square root of 4. Okay, so you'd have 3 square root of 5 divided by the square root of 4. Well, then this would simply just turn into 2, and look what you have, the same answer. So just because you don't see the shortcut, doesn't mean you can't get to the same answer. Okay? All right, same concept here. We're going to start off by getting rid of what is attached to the x, which happens to be a radical. No big deal. X equals 65 over the square root of 5. Now, we need to multiply by radical 5 over radical 5. On the top, we end up with just 65 times that radical. And at the bottom, we just end up with a number underneath the radical. And the only thing we need to do here now is simplify here and divide 65 by 5. And get 13. So x is equal to 13 times the square root of 5. Number 4, divide by the radical. Divide by the radical. Cancels. X equals radical 3 over radical 2. Now this is a little bit different than what we've done so far, because here we have an inside and inside. So this is simply going to be x equals the square root of 6. 3 times 2 is 6. Radical 3 times radical 2 is radical 6. That's all. And at the bottom we end up with a 2. And remember, the 2 does not go into that 6, because one's an inside number, one's an outside number. Hey, what's different about these problems? Whoops. Right here. They're square rooted. And you're squared. So, how do we get rid of the square? We square root. This cancels this. So now we're going to do what we learned on the first day. We're just going to simplify this. We're going to see what number goes into 80. Now, a lot of you might want to immediately go to 4, because 4 goes into 8, and that's true. But remember, we want to start backwards. And if we do that, we're going to find out that 16 is a better number to start with, because it'll get rid of all the perfect square numbers within it. Okay? It's 16 times 5. Again, if you did it like this, that's okay. You just have to remember that this would go one step further. And you have to do the same thing twice. See that? That's the radical 16. And here's your radical 5. It's not long to take 2 steps. It's just that a lot of times people leave here and go, I'm done. So, what is square root of 16? 4. So the answer is 4 root 5. Now, a little caveat here. Technically, algebraically, when we take the square root of a number, we want a plus and a minus answer. And if you're going to Algebra 2 next year, we're going to do this a lot. So I want you to remember this is important. Now, geometry, what are we going to be doing? We're going to be solving sides of triangles with these concepts of radicals. And we can't have a negative side length. So we're going to stick with the positive. But I do want you to recognize that it's always going to be a plus minus answer. So here, we square root. That cancels that, undoes it. We end up with plus or minus the square root of 21. And I'm leaving it there because there is no perfect square less than 21 that goes into it. 16, 9, and 4 do not go into 21. So that's our answer. Okay, square root, square root. Now when I do this, notice what I'm going to do here. I'm going to write the square root of 3 over the square root of 4. I'm going to split up that radical. Now one reason I'm going to do that is in this case it's much nicer because what's the square root of 4? Simply 2. So I don't have to rationalize. I don't have to multiply by anything. I'm ready to go. And the only thing to remember is plus minus. Now over here, a little bit different. X equals plus or minus the square root of 1 over the square root of 2. Now square root of 1 is simply just 1. But I do have to multiply by this to get rid of that on the bottom. So what do I end up with? Plus or minus 1 times radical 2 is just radical 2. And on the bottom, radical 2 times itself is simply 2. And I cannot simplify that any further. All right, a little bit of everything. Whoops. A little bit of everything. In this one, this is attached to the x by multiplication, so I divide. Don't have a lot of space here, so I'm just going to show this part here. You can do it either way. I end up with 21 root 3 over 3. Well, then this simplifies, because 3 goes into 21 7 times. I should just clean that up. Over here, square root. Again, I don't have a lot of room, so I'm going to simplify 28. I'm going to reduce it. This is radical 4 times radical 7. And this is simply just 2. That cancels. So x equals, remember the plus or minus, 2 times radical 7. Here, I want to square root both sides. This one's nice. Why? 121 is a perfect square. The square root is 11. The last one here, going to divide by radical 2 and it cancels. Divide by radical 2 here. Got to get rid of it. So I end up with 60 times radical 2 all over 2. Also known as the square root of 4. Well, then this is going to simplify, reduce to 30 times radical 2. And there you go. That's it.